Hi gang. Today we're going to be finishing up our videos on conversion factors, and this time we're going to be talking about using an equation as a conversion factor. Oftentimes equations will show us relationships between variables, and when we find one that shows us a consistent ratio, we can use that as a conversion factor. So today we're going to be talking about the idea of density. Density is a ratio of two physical properties. The mass of a substance divided by the volume of that substance gives us a third physical property, which is the density, the mass per unit volume. Now, the cool thing is the density of a material always remains constant. If you have a small sample of it, you have a small mass, but you also have a small volume. If you get a bigger chunk of it, you have bigger mass, but you also have bigger volume. The density of that material always remains constant. So for an example, let's consider the element bismuth. Suppose that you have a sample of bismuth and it's got a mass of 312 grams, and you measure its volume and you find that the volume is 31.9 cubic centimeters. Well, knowing the relationship or the equation for density, we can just substitute 312 grams in for the mass, put in the 31.9 cubic centimeters for the volume, and we would find that the density of bismuth is 9.78 grams per cubic centimeter. Now, as I mentioned, that's cool because that quantity is going to be true for all samples of bismuth, no matter how big they are. So we can think of that density then as a conversion factor. We could write it as 9.78 grams of bismuth over 1 cubic centimeter of bismuth, because that much bismuth, 9.78 grams, will have a volume of exactly 1 cubic centimeter. But since that ratio is the same amount over the same amount, remember, like a conversion factor, we could write it this way as well. If you've got 1 cubic centimeter of bismuth, it's also going to have a mass of exactly 9.78 grams. Well, that's useful then. If we have some sample and we know either a mass or a volume, we can use the density to figure out the unknown quantity. So suppose we've got this. Suppose you've got a sample of bismuth and you find it's got a mass of 231 grams. And we need to know what the volume is. And suppose it's irregular in shape and it's going to be difficult to just measure it directly. Well, we can use this idea of density to figure it out. And the process is just like we've done before. We're going to set up a fraction starting with what we know. And in this case, what we know is that we've got 231 grams of bismuth. So we make our original statement, 231 grams, we put that over 1. So we have a numerator and a denominator. Then we put in a conversion factor. Now our conversion factor here is going to come from the equation for density. The density of any material, remember, is mass over volume. And for bismuth, that turns out to be 978 grams per cubic centimeter. But since that's the same amount of bismuth on both the top and the bottom, we could also write it this way, 1 cubic centimeter of bismuth over 9.78 grams of bismuth. Now, again, which one do we decide on? Which one do we use? Well, we let the units be our guide. Since this 231 grams up here in our known quantity has grams on the top, we need to cancel grams out. So we look at our conversion factors and we find the one that has grams on the bottom. And that's the one that we're going to use. So we're going to use this version of the conversion factor and just plug it in up here. Now when we set it up like this way, notice that again that the unit grams will cancel out, and we multiply by all the numbers on the top, you divide by all the numbers on the bottom. So in this case the ones don't matter, because remember, ones don't change anything. If you multiply or divide by 1, it doesn't change anything. So if you take 231 divided by 9.78, the only unit left over will be cubic centimeters, and it tells us that the sample of bismuth would have a volume of 23.6 cubic centimeters. So if we have an equation, oftentimes we can use a quantity that's a ratio of two other quantities as a conversion factor, and then use that as a shortcut to calculate an unknown quantity. Thanks. Talk to you guys later.